Good evening, everyone. This is an introduction to probability and chance by me, Mr. Agostini. By the end of this lesson, students will be able to correctly calculate the probability of several given scenarios. These scenarios include the probability of different outcomes for flipping a coin once, flipping a coin thrice, flipping 3 coins at once, and flipping 3 coins at once 3 times. They will be able to accomplish this on their own with a 90% accuracy or greater. We will be starting with the most accessible and recognizable indicator of random probability, the coin toss. So, when we flip a coin, we assume that the coin will either land on heads or tails, with an even chance of either outcome. This is represented here as 1 bar of red and 1 bar of green, each representing one of the 2 probabilities. The odds of heads or tails coming up on an individual coin flip will always be 50-50, regardless of how many times you flipped the coin prior. You can flip the coin 10,000 times and all of them come up heads, and the chance of it coming up heads again is still 50%. Now, what isn't 50-50 is the odds of 1,001 coin flips all coming up heads. The difference between these two concepts is that the coin flip is always 50-50. The odds of a single event remain the same. However, the odds of getting that specific result is not likely. Here, we have a visual representation of a coin flip following our first coin flip, again with red being heads and green being tails. Notice that, regardless of what the previous result was, the chances of either heads or tails going forwards is still 50-50. However, as you can see, getting heads twice and getting tails twice is less likely than getting 1 heads and 1 tails. This is because, for the purposes of probability, getting 1 heads and then a tails is equivalent to getting 1 tails and a heads. When we flip 2 coins, there are 3 possible outcomes. Either both are heads, both are tails, or you get 1 head and 1 tails. This is shown in the diagram. Notice that the orange segment has 2 blocks compared to the 1 block for the red and green. That is because the 1 heads, 1 tails outcome can be achieved with either coin 1 being heads and coin 2 being tails, or coin 2 being heads and coin 1 being tails. This is a representation for flipping the 2 coins again. Notice, as with the first one, each individual result has its own set of results underneath it. The probability of getting any of the results is the same as in the previous state, but the results of getting 2 heads and then 2 heads again, or getting 2 tails and 2 tails again, is much less likely than other results. As illustrated, you can use a visual representation of probability and then take a smaller scale for each one of the possible outcomes in order to have a visual representation of the probability of each result. Using what we've learned, as well as this method, tomorrow we're going to construct our own visual representations, like the one shown here. You will be supplied graph paper and which probabilities you should map. If you have any questions tomorrow, please be sure to ask me, and I will help you. You are participating in a game show. In addition, I would like you to think about the following. You are shown 3 mystery doors. Behind one of the 3 doors is a brand new car. Behind each of the other 2 doors is a goat. After you've selected your door, the host of the show opens one of the 2 doors you had not selected to reveal a goat. You are now given the option to either stay with the door that you had originally picked, or switch to the unopened door. I want you to tell me why you should or should not switch. As a hint, think, what was the possibility of choosing the door with the car the first time, and what are the odds of you switching and getting the car? We'll have an in-class discussion and explanation about this problem, both its history and why the answer is what it is, tomorrow after the previous activity. I look forward to seeing everyone in class tomorrow, and please, if you have any questions, feel free to message me on the class webpage or the class group Skype call. Have a great night, everyone.